Hi, we're Group 14, and I want to ask you, have you ever experienced taking out your trash, but coming down and then seeing that the shared container in your apartment building is full? So what do you do then? Do you just leave it, take it back up? I don't know. Optimizing garbage collection is not really an easy task, since garbage containers can fill at very different rates, and sometimes someone hosts a huge party and then it's full for a week, and, well, unlucky. So, really you can fix this by just having more containers, or have trucks drive more frequently to empty stuff, but that costs money, or it smells, or, well, you emit more greenhouse gases if you have trucks driving around. So, our simulation that we've made, we hope to be able to investigate this problem further, and also, hopefully, pinpoint a better solution to what we currently have. Here is our simulation. We are running the base scenario, which means that once per week, a garbage truck will spawn and empty all containers. The grid that you see represents the city. Each colored square is a container. Containers fill up at different rates. On the left side, we have metrics for truck emissions, both total and per truck. On the right side, we have the current tick, how many hours have passed in the simulation, and overflow hours. If a container is full and an hour passes, this will add 1 to the overflow number, which means we don't want to see this rise. Let's run the simulation. When a week has passed, at around 60,000 ticks, a truck will spawn. You might notice that this truck follows a very inefficient path. We're working on improving this. In addition to the base scenario, we've ran 4 more scenarios. Each scenario is ran for a time of equal to 1 month. The first scenario, we empty only containers that need to be emptied. That means every time 2 or more containers are at the threshold, we empty those containers. Second scenario, we empty every 3 days instead of every week. And in this one, we empty all the containers. Third scenario, every week, we only empty containers that are above the threshold that we set to 50%. The last one, we empty every 3 days, but we only empty the containers that are above the threshold of 75%.
Using some simple mathematical relations, we can calculate a rough estimate for the emissions of a garbage truck and clearly see a resemblance between our results and the data from a real-life scenario. Let us take a look at the CO2 emissions, for example. A garbage truck is said to produce around 150,000 grams of CO2 per 24 hours of usage in real life. Our base case scenario represented just a truck emptying all containers after a week, regardless of their capacity, and that produced around 154,000 grams of CO2 per 24 hours. In our simulation, if we empty every time 2 or more containers are at the threshold, we get roughly 152,000 CO2 grams in 24 hours, which is very close to the real-life scenario. Similar in the other scenarios, if we empty containers every 3 days, we get around 153,000 grams in 24 hours. If we empty every week only containers that are above a specified threshold, we get around 152,000 grams of CO2. And if we empty every 3 days only containers that are above a specified threshold, we get again around 150,000 per 24 hours of usage. All which have lower values than the base case, even though the scenarios are yet to be perfected.
Nowadays, more and more people know how important it is to protect the environment and create a sustainable society. Our activities are changing the Earth's environment all the time. We hope that through such a project, there will be some good changes in the global environment. Thank you.